All right, I'll be going over problem 2 on the practice quiz for 6.1 and 6.2. It asks to graph the system of linear equations and then estimate what the solution might be. So it sounds like the answer is not going to be round integers that land right on an exact grid point. So I'll take this first one, 3x minus 4y equals 12. And there are two different ways to graph this equation, at least two. I can do the cover-up method since it's already in standard form to find the x and y intercepts. So, pow, if I get rid of this x, if I have x equals 0, then y is going to equal negative 4 times what is 12? I'd say negative 3. And then pow, if y is equal to 0, then x is going to equal 4. So that's a pretty quick way of getting the x and y intercepts. And so if I graph these points on this coordinate plane over here, x equals 0, y equals negative 3. So now we have a y-intercept right there. And then the x-intercept when y equals 0 is 4. So now that I found the x and y intercepts, I can connect those two dots. And get my first line. The other way I can do this is to change it into y equals mx plus b form, slope-intercept form. So instead of finding the intercepts, I solve for y. So I'll subtract 3x from each side. That leaves me negative 4y is equal to negative 3x plus 12. I want to get y by itself, so I'll divide every term by negative 4. And that leaves me with y equals negative, not negative, negative divided by negative is a positive 3/4 x minus 12 divided by negative 4 is negative 3. So now that I use this, if I go back over here, this agrees with what I did before. The y-intercept is a negative 3, but now my slope is going to be 3/4. It's going to be positive 3/4. So it's going to look like, I'm trying to get this right, positive. So I'll go up 3, 1, 2, 3, and over 4. It gives me that same graph. So the second one's a little bit trickier. I'll just go ahead and solve that for y equals mx plus b, solve for y. So if I have 3y plus 12x minus 15 equals 0, I'll add 15 and get 3y plus 12x is equal to 15, and then I'll subtract 12x from each side. And I get 3y is equal to negative 12x plus 15. And now I divide everything by 3 to get y by itself. Y is equal to negative 4x plus 15 divided by 3 is 5. So this is much easier to graph than this. This is hard to see what it would look like on the graph, but this is one of the great things about slope-intercept form. I know it has a steep negative slope, and I know it has a y-intercept of 5. So I'll go over here, slide this over a little bit. So y-intercept of 5 will be right here, but it has a steep negative slope. So negative 1 would look like this, so it's going to be even steeper than that. So a rise of negative 4, 1, 2, 3, 4, and a run of 1. That does look pretty steep. 1, 2, 3, 4, and then 1. And now I connect these lines, these dots. And it doesn't quite look like that intersection point, which is what we're looking for. It's not quite at 2, negative 2. Forgot to mention this is one of the classes I wanted you to round to the nearest tenth, so it's not quite there yet. And so if it's not quite 2, but it's definitely more than 1.5, I'd go with around, what do I have, about 1.7. And then right here, it looks like it's closer to -2 than -1. So your answer should be between those two. I'm going to go with -1.8. You have -1.5 to -1.9. I'm okay depending on your drawing. Just don't give me a number like -1, -3, +2. I want you to be able to determine, depending on how accurate your graph is, that you are between 1 and 2 on the x-axis and between -1 and -2 on the y-axis. So there's no one right answer. This is just an approximate, but again, it should be in that range.